In UniFi Network Controller, there are multiple ways to set DNS settings for your clients. For example, in each VLAN, if you go to the DHCP setting for DNS server, you can specify multiple candidate DNS servers so that if the client get IP address by using DHCP, it will also receive the DNS server settings, right? But this can be easily worked around by the client if they manually configure the DNS server. You may not want your clients to do that. So in this video, let's see whether we can use the Ubiquiti newly introduced DNAT setting to achieve our goal, which is to redirect whatever client machine's DNS request to the DNS servers you want. If you watched my previous video about the DNS filter, you may know Ubiquiti implemented the content filtering and ad blocking by using DNS filter. Internally, it uses DNAT already to redirect DNS request. But the problem is the content filtering and ad blocking implementation is too limited in the UniFi gateway. It doesn't open up a lot of settings and it hard-coded the servers you can use. So it may not meet your requirement. In this video, let's explore if you want to have your own custom DNS resolver, how you can use the DNAT to redirect DNS queries to your server. Because DNAT or destination NAT, the setting is on the interface level. Depending on where the client machine is and where the DNS resolver you want to redirect to, you will be surprised about how differently the DNAT rule will behave in different scenarios. So in this video, we will first talk about if your client is in the default network, you want to redirect the DNS query to public DNS server, whether it works. Then we will see, instead of using a external public DNS resolver, what if we use our own Pi-hole server inside our own network. Then we will see what if your Pi-hole server is not in the default network. In the end, we will see what if your client is in a custom VLAN instead of the default network, whether the DNAT rule still works. This is my lab environment. I have a UX3 Pro. It's running behind the main router of my home. That's why in the diagram, you can see the one part IP address is in fact my home network's private IP address. And in the right side, the UniFi network controller for internet setting for the primary one part. You can see for DNS server, I configured it to use Google 8888. And then for each VLAN, for example, default VLAN under DHCP setting, I didn't change the DNS server, it's altered, which means the client will receive the gateway's IP address, the LAN IP address as the DNS server. And then internally, it will route the DNS queries to external to Google. By default, that's how it works based on my current configuration. But in the lower part screen, you can see two Apple machines, client 1 and client 2. If I check their network settings, you can see they all have the customized DNS servers. Instead of the gateway IP address, I see 9999, not the one I set. If I do not do anything from the first Mac machine, if I dig x.com, you can see the response came from 9999 instead of 888. So this is the current situation. Let's see how we can use DNAT to resolve it. If I go to settings, routing, you can see a new tab called NAT. There are 3 types of NAT rules. In this video, let's use DNAT. Destination NAT. I already created the rule, the protocol UDP, because we are talking about regular DNS queries. And then interface, you can see you have the multiple one parts depending on what gateway you use. And then for each VLAN, you have a interface. Because here we are talking about the 2 clients in default network. That's why I am selecting the default as the interface. You may ask, we are talking about DNS DNS, doesn't it go through the one part? Yes, but here the interface is the in interface, not the out interface, meaning your client send out the DNS query, it will go into the interface for the VLAN default. That's why here I select default. Even though this is DNAT, destination NAT, I do not want to customize the destination setting because no matter what DNS servers the client set to, I want to prevent that, right? So I want to leave this destination filter unselected so that it will apply to whatever DNS servers the client set. Okay, and then for destination part, this time I have to specify something because I only want to redirect the client's DNS request, nothing else. So the DNS query has port 53. Then when it comes to source, just want to make this video more interesting. For this client one, I want to give it some privilege. It can continue to use its customized DNS server, but only for the client 2, I do not want it to use the customized query. So that's why here for source, I only filtered on the IP address of the second client, not the first one. Later we will see the difference. Then for source part, I don't care because I only care about the destination part. Here comes the important setting named as translated IP address, because the DNAT rule basically is saying it will translate the destination to this IP address. So no matter what's the destination, it will be translated to this one. For this first scenario, I want to use 1111 as the translated IP. So I want the client to redirect the DNS queries to 1111. And then of course the translated part is 53. Pretty straightforward DNAT rule. Before we see how it works in action, let's go to the backend of the UniFi gateway to see how Ubiquiti implement this DNAT rule. Let me SSH into the UXG Pro. Okay, I'm in. Let me run this command, IP tables. I'm only interested in the NAT tables. I want to see the detailed information, and I only want to see the DNAT rules. See, there's only one DNAT rule generated. It corresponds to the rule we specified on the UI. So let's look into it. Target is DNAT and the protocol is UDP. Interestingly, see the interface here is using the bridge as the interface, BR0. You can use another command, BRCTL, bridge control, and let's show the BR0. As you can see, its physical interface is the LAN part, the S3. So the interface thing will be very important in our future scenarios as well, because it will cause us problems. This is the in interface. This is the out interface. You can see the out interface is any. And then this is the source, client to Mac machine, and the destination is anywhere, just like what we specified on the UI. Here it specified how it will be translated. It will still be UDP. DPT means destination port. Domain means DNS, meaning 53. And here, this is the important part. The final translated IP address is 1111, as we indicated on the UI. This is how the DNAT is implemented in the backend. Okay, now we can see how it works in action. To understand how the traffic is really routed, let me run TCP dump in the UniFi gateway. Here what I'm saying is I want to capture the packet for all the interfaces. I only care about port 53. Let me start it. There are some annoying noises, even though now we haven't started our testing yet. You can see some frequent DNS traffics. That's because the gateway itself is doing the connectivity and the latency testing. They have nothing to do with this video, with our testing. Now let me start from the client 1. If you check the diagram, you can see the client 1. I do not want to redirect its DNS traffic, right? Let me run digx.com. Okay, something's captured. We will check the details later, but let me move on to the second client machine. Let me run the exact same command. Okay, done as well. Let me stop capturing in the gateway. Let's examine the interesting results from the client machine 2. If you just check the two clients' reply, you may see they are identical. Interestingly, they are both from 9999, even though for the second machine, we expected to get result from 1111. That's how our DNAT rule is set up. But here it says it's from 9999. It did get result back, no problem, no issues. This client still thinks it's getting result from 9999, which is the one it customized in the DNS setting. The client is not aware of any internal redirection at all. Let's check the captured frames. Let's first check the client 1's query. Okay, starting from this one. The interface is S3, which is the LAN part of the gateway. And the machine is the first client machine. The destination is 9999 and the query is x.com. That makes sense. And then see the second one. This time, other information is the same, but the interface changed. Now it's BR0 because it's default network. It also makes sense. And then see the third packet. This time the interface is S0, which is the primary one part. And see the direction is out. And the source IP address is the one part IP address, because this packet is not the one inside my local network anymore. It's going out of my gateway, going to the external world. That's why the interface changed. The source IP address, it becomes my one part IP address. And the destination is still 9999. And then the next one, the one part, the direction is in, so it receives reply from 9999. And then the traffic is routed to BR0, and in the end routed to S3, go back to the client machine. You can see how the client machine, gateway, and the destination 9999, they interact with each other. Then let's check the more complicated case for the client 2. Starting from this packet. See the interface is S3, the same LAN part of the gateway. Direction is in, is from this second client machine, no problem. The destination is 9999. Why 9999? Because in the client machine, we customize the DNS server to 9999, right? No problem. One, the second packet interface is changed to BR0 because it's default network, and the source and the destination IP address remain the same. No problem. See the third packet. That's where the magic happens. This one is the one part, is S0, right? The direction is out. And then the source IP address is the one part IP address, no problem. But interestingly, the destination, it becomes 1111 instead of 9999. Why this happens? This is the result of our DNAT rule. Because in our DNAT rule, we say we want to translate whatever the destination IP address is, as long as it's part 53, I want to translate it to 1111. Now you see the effect of the DNAT rule. See the next packet is one part again, and the direction is in, is the reply from 1111. And the reply to whom? Not directly to our client, because our client is in our private network, right? So the 1111 will reply to the one part. And then this packet has another magic. Instead of saying 1111 reply to the client machine, here it says 9999 replies to the MAC machine. Why this translation? Because the DNAT rule will not only translate when the packet come into the interface, but also the reply. So this packet is the reply. And see the interface is BR0. Remember we checked the IP tables DNAT rule. The interface is BR0, right? This is the translation for the reply. It changed the IP address from 1111 to 9999. And then the very last packet is where the client machine received the results finally. And you can see the source IP address is 9999. So which means the whole DNS query process is really getting result from 1111. But the client thinks it's getting data from 9999 because of the DNAT translation here. Okay, now you see how it works in action. So this is a successful testing for this particular scenario. Let's move on to next scenario. So this one is similar to the first one. The difference is instead of directly using the external 1111, I want to use my local network's Pi-hole server, and then Pi-hole will forward the queries to 1111, which means in the DNAT rule, instead of translating the IP address to 1111, I need to do the translation to this Pi-hole server's IP address, right? For this scenario, both the clients, they are still in default network, and the Pi-hole server is also in default network. In the UniFi network controller, let me edit the existing DNAT rule. The only change I need to make is the translated IP address. I need to change it to the Pi-hole server's one, right? And then when it comes to interface, it should still be default network. Apply changes. Then let me try in the client 2. Let me dig x.com. See, this time is the unexpected result. You see the error. It expects to receive result from the 9999, but instead it receives result from the Pi-hole server. And then the DNS client refused to continue. We have a problem. To understand what's the reason for the issue, let's start the TCP dump. Then we can see what happened inside the gateway. In the gateway, let me run the same command for TCP dump. Okay, it started. Then from the client machine, let me do the dig again. Okay, something's captured. Stop it. See, starting from this packet is for our testing. The interface is still S3 because we are talking about the default network, the LAN, and the direction is in, and the source is the client 2 machine. No problem. And the destination is 9999. No problem, right? So the very first packet, we don't have a problem. Then the second packet, interface is BR0 because it's default network, right? It makes sense. Direction in and the source IP address, destination IP address remain the same. Makes sense. The third packet. See, this time is BR0 interface. The direction is out, and it's from the client 2 machine to the Pi-hole server. Initially, it was 9999. Now it's Pi-hole server. Why is that? It's due to our DNAT rule, right? We want to translate the 9999 to Pi-hole server's IP address because that's exactly what we want. Okay, this packet also understandable. Move on. The fourth packet. This time is the S3. It's the LAN part. Now we have a problem because client 2 and the Pi-hole server, they are both in the same VLAN, the default network. So for these two machines to communicate with each other, the traffic doesn't need to go through the router, which means the client will directly connect to the Pi-hole server. That's why we have the issue from the client side. The direction is out, the same client 2 IP address and the Pi-hole IP address, right? The whole process just stopped here without being continued because right after this packet, the client realized something's wrong. It wanted to query 9999. Now it's sending the request to another IP address. Why in previous scenario we didn't have the problem? It's because for the previous scenario, we translate the destination to an external public IP address. So the traffic need to go through the gateway. But for this scenario, the client can directly communicate with Pi-hole without going through the gateway. So the client realized the problem. That's why this scenario failed. Okay, that's unexpected result, right? Basically, we failed this scenario. Let's move on. In the third scenario, let me slightly change the Pi-hole server. Instead of putting it to the default network, now I put it to VLAN 10. So now it resides in different VLANs as the client. Let's see whether this time the DNAT rule works or not. Of course, we need to modify our existing DNAT rule. The only thing I need to change is the translated IP address. I need to change it to the new VLAN 10 IP address for Pi-hole. Apply changes. You can see I keep the interface as default, not VLAN 10. So then from the client 2, let me dig x.com. Okay, this time you can see the result is correct. It is still showing the server is 9999 and it did get result back. If we go to Pi-hole server, from the query log, I can see this from the client 2 and it queried x.com. So this log proves our DNAT rule works. Client 2 reach out to Pi-hole to finish the DNS query instead of directly reaching out to 9999. We still want to understand why this time works. So inside the UniFi gateway, let me run TCP dump command to capture packets. Okay, then from the client 2, let me dig x.com again. Okay, something's captured. Stop it. Let's try to understand what happened. So starting from this, no surprise. A second one, no surprise. Exactly the same as previous one. But starting from the third packet, it's different. See the interface? Now it's S3.10, which is for VLAN 10. Why VLAN 10? Direction is out. Why is that? Basically, that means the gateway sent the packet to the Pi-hole server, which is in VLAN 10. That's why the direction is out. That's why the interface is S3.10. This makes sense. And then the source IP address is the client machine. The destination is the Pi-hole server. Okay, and see the next one, the same VLAN 10 interface, and the direction this time is in, and the source is the Pi-hole server's IP address, and the destination is our client machine. At this time, the client machine hasn't received the reply yet because it still need to go through the BR0. See the BR0, the direction is out, and all of a sudden the source IP address is changed to 9999. That's our DNAT rules effect. Because this is for the reply, the DNAT rule will automatically translate from the Pi-hole server's IP address to 9999. At the very last step, this time is at 3, is for the default network for the LAN part, and the direction is out. From the client perspective, it receives the reply from 9999 and the destination is the client. So that's why from client perspective, it didn't feel any difference. It still thinks the result is directly from 9999. That's why the whole process was a success. Okay, so now you see the difference if we put the Pi-hole server in different VLAN, right? It will lead to different result. The very last scenario for this video will be short but very disappointing scenario. Instead of putting Pi-hole server to different VLAN, now I want to keep the Pi-hole server in default network but put my client in different VLAN. Now the client is in VLAN 20 and it has this new IP address. So let's see whether this time it works. Let me modify the existing DNAT rule. I need to change it in multiple places. First, the interface, it should be the interface for the client 2. Let me choose VLAN 20. Then the source IP address is changed to the new VLAN 20 IP address for client 2. Then for the translated IP address, I need to change it back to the VLAN default IP address for the Pi-hole. Okay, I change it in 3 places. Apply changes. Then from the client 2 machine, let me dig x.com. Okay, it got result back and it is showing 9999. It seems that's exactly what we want, right? You may think, okay, this time it also works. But hold on a second, let's validate it from the Pi-hole. In Pi-hole server, I cannot find this DNS query from the client 2 machine, which means the client 2 didn't reach out to Pi-hole server at all. And to furtherly confirm that, within the UniFi router, let me launch the TCP dump. Then from client 2, let me dig x.com again. Okay, something happened. Stop capturing. Starting from this packet, that's for our testing. So you see the interface. Now it's changed to S3.20 because the client 2 is in VLAN 20, right? That makes sense. And the source IP is for the client 2 and the destination is 9999. Okay, the first packet makes sense. The second packet, see, it immediately reach out to one part, reach out to internet, and the destination is 9999. So the client 2 is still using its own customized DNS server, which is 9999. It finished at the fourth packet, and the whole process has nothing to do with our Pi-hole server. Our DNAT rule failed for this scenario. So let's understand why is that. Let me display the IP tables and to find out what's the generated DNAT rule. And see the interface is BR20. This is a weird one. Just from the wording, it seems to be a bridge for VLAN 20. But if I try to show the details for BR20 using bridge control command, you can see the bridge doesn't exist. So the way I see it is it's a bug. The DNAT rule is using a interface which is called BR20, but it doesn't exist. If you think it's not a bug or if you have any comments, please let me know in the comment area. But basically this scenario failed due to the BR20 thing. It simply doesn't work. Okay, this is the end for the video. Thanks for watching.